Alright, the stream seems to be running, and hopefully the sound will be better than yesterday. Or it might not be. So yesterday the problem was that I had a really weird echo, but I could never quite track down where it came from. But hopefully it won't happen again today. Right, so plan for today is we're going to solve Advent of Code Day 2. But before we actually start on Advent of Code Day 2, I want to do something about this pretty horrible thing I wrote for part 2 yesterday. Like, don't get me wrong, it's functional, but I think the fundamental reason I did it was wrong, and, well, it kind of looks terrible. Okay, so, first off, why the hell did I do it like this? Why did I do it based on char lists and not on binaries? Well, the thing is that binaries in Elixir are immutable. You cannot change them. You cannot change characters in them. You can certainly not add characters in the middle of them. So my reasoning was, but lists, char lists in particular, are a lot easier to manipulate. And in the first version of this code, we were basically replacing the 3 letters of O and E with, say, the letter for 1, the character for 1. And I figured this would be better than doing it in a binary. However, this reasoning made no sense at all, because we're not actually modifying the input here. We can't be, because Elixir doesn't have any mutable data structures. So what we're in fact doing is taking an input and then generating a very similar output. Or rather, we were generating a very similar looking output until I switched to just outputting numbers. And now the whole charade falls to the ground, and it's obvious that this is just bad. So, I think I can just do this with binaries, and once we do that, we're going to check to see if I'm right and Elixir actually optimizes this case away. So, let's start a new block for this. So the basic thing I claim is going to work is this. Def module AoC2 do, right, def digitify. So I should be able to just match on the binary here and do this, 1. And then here, rest. And then do 1. And, well, does the digitify of rest. Do I want digitify of rest? No, let's just do rest for now, just to see that it works. And now if I call digitify on 1, 2, 3, I expect this will return a list of 1 and then 2, 3, the binary. Right. Need to specify the module. No function clause matching. Okay, no, so Elixir binary matching. How does this work? Binaries, bit strings, whatever. Right, so this is the syntax, is it? Yeah, this looks like the right syntax. So why did it not work here? No function clause. What does it actually oh, do I need to do here? I need to qualify that, right? Because otherwise, yes, I need to say this is a binary. Okay, now it works. So the problem before was that since rest wasn't given a type, it was just assuming it was a single byte, which of course didn't match. And then, yeah, this did exactly what I expected. Okay, this is good. So instead of rest, we're going to be doing digitify. Now we have the other problem. Okay, we can do this. We can do this. So this is the input. We're going to call it str. And then I want string tail. Is string tail a thing? What's TL? Does this work on strings? No. Is there something here I can use to just grab everything except for the first character? Elixir, everything except for the first byte of a binary. Surely somebody's had this problem before. Nope, these are not helpful suggestions. Is this a better suggestion? I'm looking for a function that will do this better. No. Okay. Oh, but we can just write our own function, can't we? Yeah, we can. Okay. So we're just going to say, well, let's call it what? Tail. Tail is a good name. Tail of str. And we don't need to give rest a name anymore. Right, the tail. So this takes binary, the first character, and then the rest is a binary. This returns the rest. Yes. Right, so what happens if we run it here? Okay, it works. It returned NE23, which is indeed the tail of the original text. Okay, so instead of tail, we want to actually do the GTA5 of this. Right, now we need to copy this a bunch of times, but now it's going to look a lot better than yesterday's thing. 3, 4, 5, 6, 7, 8, and 9. And we need to change the numbers as well. So it's 2, 3, 4, 5, 6, 7, 8, and 9. Okay, what other base cases did we have? Oh, what happens when it's not one of these things? So if it's not one of the matching... Oh, if it's an actual letter, if it's an actual character, when C in... Then here we do C minus 0. Okay. And then if it isn't anything, if it isn't a letter, we can just keep on going. Okay, and then the base case is what happens when we end up with an empty binary, which we can just write like this. Yeah, this looks nicer. This is going to be an empty list. Okay, and now if I run this, it should return what? It should return 1, 2, 3, all the numbers in a list. Syntax error. Syntax error. When is reserved? Oh, no, I have an extra colon. Colon, comma. I have an extra comma. Okay. C minus 48 looks like a function. 1, 2, 3. Okay, this worked. Good. Now, just going... What were we doing here? This... Yeah. So this was the thing. This was the code that actually takes the input. So it reads the input, splits it into lines, calls digitify on every single line, then constructs a 2-digit number from the first and last digit in each line, then computes the sum. And this should result in the same thing as above. Okay. And this is, yeah, like this is way more readable than this crap. Still not good though. Yeah, it's still really error prone in how it's actually written, but a lot better. A lot less obscure at least. Okay. Done. So this was day 1 again. Now let's look at day 2. Where do I see calendar? Calendar. Okay. Day 2, Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. Oh, on the first day we got launched out of a trebuchet, and now we've fallen into a fluffy pile of leaves somewhere. Somewhere without a lot of snow. Okay, the elf explains that you've arrived at Snow Island, without the snow, and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? Maybe? As you walk, the elf shows you a small bag and some cubes which are either red, green, and blue. Okay? Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. So he will hide a secret number of cubes of each color in the bag. Okay, so his bag is going to have some number of reds, some number of greens, and some number of blues. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, grab a handful of random cubes and show them to you, and then put them back into the bag. He'll do this a few times per game. Okay, so he'll show me a sample of the random cubes in his bag. Okay, you play several games and record information from each game. Your puzzle input. Each game is listed with its ID number, like the 11 in game 11. Okay, followed by a semicolon separated list of subsets of cubes that are revealed from the bag, like 3 red, 5 green, 4 blue. Oh dear, this is going to involve parsing. But you should be good at that at this point. For example, the record of a few games might look like this. Game 1. 3 blue, 4 red, 1 red. What's a semicolon? Semicolon. Each game is listed with its ID number, followed by a semicolon separated list of subsets of cubes that were revealed from the bag. Okay, so these are the random samples of cubes he pulled from the bag. So it's 3 samples there, 3 samples here. Is it always 3 samples? 3 samples again, 3 again, and only 2 samples here, so it's not always 3 samples. In game 1, 3 sets of cubes are revealed from the bag, and then put back again. The first set is 3 blue cubes and 4 red cubes. The second set is 1 red cube, 2 green cubes, and 6 blue cubes. Okay, and the third is only 2 green cubes. The elf would like to know which games would have been possible if the bag contained only 14 red cubes, 13 green cubes, and 14 blue cubes. Okay, so we don't actually have to guess the number of cubes of each color in the bag. We just have to check whether it's possible. In the examples above, game 1, 2, and 5 would have been possible if the bag had been loaded with this configuration. However, game 3 would have been impossible because at one point the elf showed you 20 cubes at once. 20 cubes at once. Similarly, game 4 would have been impossible because the elf showed you 15 cubes at once. 15 cubes, right? If you add up the IDs of the game that would have been possible, you get 8, right? Because it's 1, 2, and 5. Determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games? Okay. So this is not hard at all to compute. The difficulty is in actually parsing this. We can either do this manually by writing our own little custom recursive descent parser, or we can use a parser combinator library. I'm probably going to regret this, but let's try writing our own recursive descent parser. Should be pretty doable. Well, famous last words, but should be pretty doable. Okay, first off, new notebook. This is AoC day 2, AoC day 2. Yeah. Where do we save it? We save it in repo, the AoC 2023, day 2. Okay, this is going to be the setup section. We're going to need at least key now for reading the input. Okay, and here we have input is keynow.input.text. Text area. And we're just going to call, okay, so based on yesterday's experience, we're going to need both the example inputs multiple times and the actual full inputs once. So this is going to be example part 1. Example 1. Okay. Next we need, oh, we should copy it in. Yep. To clear my clipboard because there's always problems with the clipboard otherwise. Okay, section 2. So this is going to be part 1. I want an Elixir block. First off, input read example 1. Did this work? Yes. Then we split it into lines. So string split. This did not do at all what I thought it would do. A string split on new line. Okay, this is better. But that string split just now did give me an idea. We can split on spaces, and that will make our parser way easier to write. Okay, nice. So, we're going to have... yeah, we're going to parse this into a much nicer data structure, and then we're going to do the analysis required on it. So num.map, left-hand line, and parse line. Okay, and now we have to write, this is going to be, this will need to be in the module, AoC parse, module, AoC, do, and map, parse, okay, line. Let's do it like this. So this should now return a list of 5 OKs and then the lines themselves. Good. So first off, if the input is a binary, we're going to split, we're going to do something we'll charitably refer to as tokenization. We're just going to be splitting on white space. So when is binary line, then we're just going to call parse again with string. Can we do it like line string split parse? Okay. Then when we get parse and we have tokens, yeah. So this has to be a list to match. Now we do our OK tokens thing. Okay, so this is tokenized of a sorts. Can we do better? Yes, so the first thing we have to match on is a game. Every line starts with the word game, and then there's going to be a number followed by a semicolon. The string split do. Can I string split on colons as well? I'd love to get rid of that colon. String split. Divides a string into substrings at each Unicode white space occurrence. Yeah. Pattern. The pattern may be a string, a list of strings, or regular expression. Okay, so we're going to make this a list of strings. We're going to split on space and colon. Okay, there's a strip, isn't there? There's definitely a strip. There's a trim option. Trim true. Okay, better. Let's put this on multiple lines because it's getting hard to read. Okay. So we're now splitting on spaces and columns. So when you get game 1, then we have 3 blue, 4 red, and a semicolon. That's annoying. I'd like to... Well, we'll get to that when we get to that. Alright, so to start off, we've just... Alright. So here we're going to call parse game instead. Yeah, parse game. Parse game always matches on a list that starts with game, then the number of the game, and then the rest. And this is going to return... This is going to return a map, a game with the number, and let's just call this tokens rest. One extra call, one extra comma. Okay. So we're now successfully parsing... Well, we're not, because the number should be converted to an int first. This is string to integer of none. And this cannot be a single line function anymore. Okay, we're now parsing the game number, which is a start. And then instead of tokens, we're going to have, what do they call them? We call them something. Each time you play a game, he will hide a secret. Yep. The elf will reach into the bag and grab a handful of random cubes and show them to you. Okay, the semicolon separated list of subsets of cubes. Okay, so we're going to call these subsets. Subsets, parse, subsets, yep, plural of rest. Okay, parse subsets. So a subset is always something that starts with A subset is always something that starts with number, then has a color, then a number, then a color, then a number, then a color, eventually followed by... So a subset is ended by a color with a semicolon at the end. Right. So if parse subsets is called with just one argument, the list, then it means we're currently we're currently in the top level case. So, oh, num and color, followed by other stuff. Yeah. Now the question is if color is in one of has a semicolon at the end or not. Do we have string ends with? We have string ends with. So string ends with returns true if suffix ends with any of the given suffixes. Okay, can we do this? This feels lopsided, asymmetric. So I'm trying to think of a way to write this that isn't going to be asymmetric. Yeah, basically I want take while, don't I? Now that I have these tokens, I want to take while from them until I get to a string that has a semicolon at the end. Yeah, all right. Take while and then take while. This sounds promising. So takes elements from the beginning of enumerable while fun returns a truthy value. Oh, actually what I want is more like split rather than split while. Splits an enumerable into two at the position of the given element for which fun returns a falsy value. False. Okay. Not sure how this is going to look like, so just yeah, this still works. Let's try a new block and see what split while does. Yes, split while. So split enum dot split while. So this takes an enumerable. Let's say our enumerable is going to be 1 green 3 red with a semicolon, followed by 2 blue without a semicolon, and our predicate is string dot ends with semicolon. What does this do? I need a question mark. Okay, this is going to return all of them. Why? Because string ends with is always false, so not string ends with. Okay. Yeah, this is okay. This split slightly at the wrong position. There's no way to get around this. So maybe find is what I actually want. Split with. With the first is containing all the elements in enumerable for which applying fun return the truthy values. Okay, this is not good. This just splits. This just separates the list into two. All right. Do we have find? Find index, similar to find, but returns the index. All right. Find index. Now I don't want this negated anymore. Okay, this returns 3, which is 0, 1, 2, 3. Okay. And if I have this index, let's just save the list somewhere. List. Okay, what happens if I do list of everything up to 3? This is not valid Elixir syntax. This is not Rust. So enum take list idx. plus 1. Okay, this is looking more like what I want. Then if I do drop, this gives me the rest of it, right? Do I have something that is take and drop? Is that split? It feels like it should be split. Okay. Splits the enumerable into two enumerables, leaving count elements in the first one. So split. This should give me both the thing at the front and the thing at the back. Okay. So this is how we split our games into subsets. All right, so back to here. We need to parse subsets. We have one of these lists of one green something something. So first thing we do is we match. We do case enum.find index x's, and then what is it? It's string.ends with 1 and semicolon. 2 and right. So this has to be a case because there's always the chance that we don't find an index, which probably returns no. Does it? Find index. Yes, it returns nil if we can't find the element. So if it's nil, that means that the current thing is the whole subset. So we're just going to return parse subset of x's because the whole thing is a subset, and then we're going to return it as a list because this will have to all return lists. If not, we found an index. In this case, what do we do? In this case, we have let's call it x is 1 and rest. And this is going to be a num.split x is at index plus 1. So x is 1 is our first subset, and the rest is potentially more subsets. So the return value of this is going to be parse subset of x is 1, and then parse subsets plural of the rest. Okay, and now parse subset singular of x's. Let's just return this to see that it works. It does not work. Why? Unexpected reserved do. Oh, I have an extra colon again. Comma again. Alright. So we have 3 blue, 4 green as a subset. Yep. Then 1 red, 2 green, 6 blue. 6 blue, yep. And then just 2 green. Okay. Alright, this works. Yeah, this looks plausible. So now we just need to parse the subset. And how do we do that? Okay, we have, so each subset now is going to be a number, then a color, then a number, then a color, then a number, then a color, and so on. And the colors might also have semicolons at the end of them. Oh, so I probably wanted this to be a map because I know that we're later going to be comparing, we're later going to be doing stuff on the specific numbers of colored cubes. Oh, and I just realized the colors actually have columns in them. Huh, lovely. Okay, so parse subset. Chunk. There's a chunk function, isn't there? Chunk by. What does chunk by? Splits an enumerable on every element for which fun returns. No, I want chunk every. Chunk every returns lists of lists containing count elements each, where each new chunk starts step elements into the enumerable. So enum dot chunk every x is 2. Is this what I want? Yes, this splits them correctly. Yeah, all right. Now each one of these I'm going to... What am I going to do? I'm going to indent everything, and now I'm going to do enum.map fn. Do I want to do fn? No, I'm just going to call something. I'm going to say parse chunk. Yeah, parse chunk f1. I'm doing it like this because it just feels way easier to do pattern matching at the top level. So a parse chunk is always two things. It's going to be a number and a color. Yeah, so this is going to return what? This is going to return parse color, and then string to integer of no. And then putting the color first because this is going to actually be an atom, and then we're going to turn this list here into a map. So the atom needs to be the first element in each pair. Okay, the parse color. Right, so this is the slightly annoying thing. So we have red, green, blue, right? Red, green, blue, right? And we have two versions of each. This is red. This is also red. Oh, and I can take advantage of Elixir's, or rather Erlang's better pattern matching for this. So this is red, yeah. So now I can do green, blue. Green and blue. Okay. The following arguments were given. Green without anything. Okay. Huh. That's surprising. Can I do this? No. The following arguments are given to AoC parse color. How do I do optional? There has to be some way to say, I probably just need to say binary, don't I? Binary. Right, because if I don't say binary, it assumes it's a single byte. And in this case, a single byte isn't always correct. Okay, so now we have the correct thing. So for game 1, we have blue 3, red 4. Blue 3, red 4. Then it should be red 1, 2, green. Red 1, 2, green. Red 1, 2, green, 6 blue. And blue 6. Okay, this works. Next. Let's not call it subset anymore. That's not really helpful anymore. We're instead going to do enum into a map. Okay, so now we have game 1 subsets, and then the subsets, but as actual maps that we can index into nicely. Alright, so now we have the games. Next, we need to actually do their logic. Blah, blah, blah. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. So for this to happen, for every game, for every subset, the specific number, the numbers corresponding to each color have to be less than 12, 13, and 14. Red, green, blue, 12, 13, 14. Okay, so this is a filter. Enum.filter. Okay, then we get a game, but we don't actually care about all of the things. We just care about subsets. Subsets. All right. 12, 13, 14. Now we need to do something like enum.all. Okay, enum.all exists. enum.all and the function. So it's subsets enum.all. So for each subset we need to do something. What do we do? Well, for starters, let's just print it to make sure everything still works fine. Yep, okay, we're checking all of these things. And for each subset, what we really want to do is check if it's valid. So let's make this a function. Let's put it here. Subset valid. Okay, this is a subset and it's going to take a map. Name pattern matching like this to make sure that we actually get the map and not some random crap. Okay, and for each, we need to do the following. Map.get. I'm using map.get because I need the default value. So map.get map red value is 12. This is less or equal than 12, right? 12 red cubes, yeah. 12 and map.get map red, green, and blue. Okay, and now here we need all of the subsets to be valid subsets. Subset valid question mark 1. Let's put a question mark here because that's how that's the Elixir naming convention. Okay, so this should now return only, well, this will fail first because I'm missing a module, but then this should only return a few games, right? 1, 2, and 5. In the example above, 1, 2, and 5. Okay, and we have to return the sum of these, so 8. Alright, enum.map, then, so this gets game, num, and this is 1 to 5, okay, and now we do enum.sum. 8, alright. Now let's get the real input. Let's see how this works. Now here I want a separate input for this. Input.text area real input. Okay, and I'm going to clear my clipboard because otherwise annoying things happen later. And here, instead of example, we now have input 2105. 2105. Will this work? That's the right answer. Yay! Okay, we have 1 gold star and are closer to restoring snow operations, whatever that means. Let's continue to part 2. Okay, the elf says they're supposed to stop producing snow because they aren't getting any water. Oh, the elf says they've stopped producing snow because they haven't gotten any water. He isn't sure why the water stopped. However, he can show you how to get the water source to check it out for yourself. It's just up ahead. As you continue to walk, the elf poses a second question. Oh, so we're still playing games with the elf instead of fixing the water source. Lovely. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? In each game, okay, so we basically want the maximum number for each color, for each subset, for each game. Again, consider the example games from earlier. This is the same example, this is the same example. In game 1, the game could have been played with as few as 4 red, because this is the biggest red. We need 2 green and 6 blue. 2 green and 6 blue cubes. If any color had even one fewer cube, the game would have been impossible. Fine. And game 2 is just 1 red. It's 3 green and 4 blue. Game 3 would have been 20 red, 13 green, and 6 blue. 20 red, 13 green, and 6 blue. Okay. The power of a set of cubes is equal to the number of red, green, and blue cubes multiplied together. So the power of the minimum set of cubes in game 1 is 48. Why is it 48? Because 4 times 2 is 8, 8 times 6 is 48. In games 2, 5, it was something. Adding up these respective 5 powers produces sum. For each game, find the minimum set of cubes that must have been present. What is the sum of the power of these sets? Okay. Alright, this is not actually going to be hard because you already have the parsing, so we just need to do a bit of different munching. Let's have a new section, correlate part 2. We're just going to depend. Shall we depend on this, or let's move AoC to the startup section? Yank. Pop up. Paste. Does this work? Yep. Okay, going back here, deleting this. I wish I had a bigger screen, at least on Twitch. Okay. Module AoC is already defined. How do I restart this? Reconnect and set up. Maybe no. Evaluate. Okay. 2105. Right. We don't need this. This was the example, or this was the place where we were playing. So here we start with the example again. Input read example. Right. This is how it works. We split it on new lines. Okay. Next we parse. AoC.parse. The first thing. Right. We now have the parsed games. So next we need to determine the smallest number of colors for each game. So for each game means we have another map. Is it a map? And we're going to have to output some sort. We're going to have to output the product of the maximum number. Yeah, but let's compute the maximum number first, because that's going to make everything so much nicer. Right, and here, do I need the game numbers anymore? Adding up these 5 powers. No, I do not need the game number anymore. So, don't need that. So here we're just going to get rid of the top level map. Subsets. New line. Okay. So a subset is a list. We need to determine some sort of maximum for the list. Well, there's probably a better way of doing this, but I'm just going to do it with a reduce. So subsets gets parked into reduce. Reduce takes as its accumulator red 0, blue 0, green 0, red, green, blue. This is the initial minimum number of cubes of each color that we need. Then we're going to take, subset. Let's just call it X because we're going to be referencing it a lot. And max. Max is already named. Let's call it the AC. Not the greatest naming, but it should be self-explanatory. Right. So next we have to return a map. The map is going to have red in it. green in it, and then blue in it. But what's red? It's going to have maximum of AC red and X red, right? And this is going to be max of AC green and X green. And this is going to be max of AC blue and X blue. Green key not found in, right? Because the key might just be missing. So we know that our accumulator always has all the keys because we define them here. But X might not have, the subset of in each key might not have the key. So we're going to instead do map.get X red 0, and that's the default. Map get X green 0. Map get X blue 0. Okay. So now these should be the minimum number of cubes for that each game needed to be played with. So first one should be 6 to 4. God. Oh, and that's in the annoying order. So it's blue 6, green 2, red 4. Blue 6, green 2, red 4. Okay, next one is going to be blue 4, green 3, red 1. 4, 3, 1. All right. Next, we're just going to multiply these, I guess. And then dot map is map.values a thing? Looks like it. All right. And let's just pipe these into enum.product. Okay, 48, 15, 60. 48, 12, 48, 12, 15, 60, 630, and 36. 630 and 36. And now I need the sum of these. 2286. 2286. All right. And now we just have to pipe our actual input in this and see what happens. I wonder if this is actually going to be right. There was, on day 1, the question was a trick question. And I didn't spot the trick there either until I submitted the input. So here, is this a trick question as well? It might be overflowing, but this doesn't look like a number that overflowed. Oh, YOLO, I guess. 32422. 72422. 72422. Is that it? That's the right answer. Yeah. All right. And that's it for day 2, I guess. Can we make this nicer somehow? Like, the parsing is pretty bloody clunky. Cha-cha-cha. But it is fairly self-explanatory. The only way to improve this really would be with proper parser combinator library. But I'm not sure it's actually worth it here. Like, this is... yeah, this is pretty simple. What parser combinator libraries do we have in Elixir? Hex.pm. Parser. Combinator. NimbleParsec. I've definitely heard of this one, and it's got like 2 million downloads. I've also heard of Ergo, but this has no downloads. Okay, so one of these two. Let's go with NimbleParsec. Oh, it's one of Jose's things, so yeah, we're definitely going with this. Okay. Simple and fast library for text-based parser combinations. This does actually look really nice. All right, let's try it because we don't have to actually delete anything. right? We just have to make another module. Module AoC2 do end. Yep, and there's going to be a parse. Our interface is going to be the same in both for both libraries. Parse when is binary line. Yep. When is binary line. And AoC2 parse. I just want an example. Any example will do. Actually, I just want all the first examples. Why do one example when we can do all of them? You know, input read example 1. String split on your lines, and then just enum parse. AoC2 parse. Yeah. Enum parse, no enum parse, of course, it's called a map. All right. So we need to add the dependency NimbleParsec. Is this actually going to build? Or is there going to be some breakage here? Nope, builds. Should have faith in Elixir. Alright, now how does NimbleParsec work? I don't get this binary thing anymore. Import NimbleParsec. Right. Import NimbleParsec. And then apparently we're supposed to call game, I guess? Let's call it game. Is this how you write it? Oh, that's interesting. It's got magic. Of course it's got magic. So it's not going to have the same interface. It's not a def, it's... Let's do something simple. So it's going to be string game followed by piped into, of course, what's white space. Oh, never mind. Not white space. It's going to be string space, and we'll fix this later. Integer piped into string colon piped into what? Date concat time. Okay, performance, composable, no runtime dependency, sure. But how does this actually work? Does it have... It does not have a tutorial. This question is, do we have... Where's the string thing? String, string, string. Here, string. Defines a binary value. Defines a string binary value. What? So this is always a specific thing, okay? Where? How do you get a value out of this thing? You do def parsec, then you do date, which is all of those things. And it will return, oh, it will return integer. Here's the integer. Then another integer, okay. Then the third integer. right? And then this 14 is going to be this integer, then 2, 2, and then optional string 0. And it has to include a z because otherwise you don't know that it's not optional. Right. So integer 2 is one of the things that matches. What's this concat time? What's concat? Concatenates two combinators. Okay, so the concat thing is written weirdly here, but this just says that a date time is a date concatenated with a time, which makes sense. And choice chooses one of the given combinators. How does choice work? Oh, so we have a repeat. ASCII char is a thing. Def parsec. The parser is a function that receives two arguments, the binary to be parsed and a set of options. So this is the thing that gives you... Okay, what happens if I just leave it like this? And then here do def parsec game. Probably can't call it game then, can I? Def parsec parse. This defines a line, right? Def parsec parse. Back to the example. So I have to give it a name and then a bunch of combinators. And in my case, I just want one combinator. I just want game. And I want debug true. Expected min or max to be given. Oh, until 2. Oh, so this prints a bunch of debug information, and then it says, okay, so the result of that parsec is the result of the parser, and then the rest that wasn't parse. Fine. Okay, so now I guess we want here repeat. Is it repeat? I want... So, okay, so a game is then followed by multiple subsets. And the subsets are separated by semicolons. Actually, there's also a bunch of white space here I'd like to get rid of. How does white space work? WS? No, no WS. What's empty? Empty is an empty combinator. EOS is the end of string. What's label? Label adds a label to the combinator to be used in error reports. I don't care about this. Repeat and repeat while. Wait, first tag. Tag tags the result of the given combinator into tag in a tuple with tag as the first element. Okay. So I actually want that. Here we're going to do tag game now. Does this work? Yeah, this is honestly not all that helpful. Times allows the combinator to repeat a number of times. Repeat. Allow the combinator to be given on to repeat to appear 0 or more times. Alright, so what do I want? Where's repeat while? Repeat while repeats while the given combinator. I don't think I care about repeat while, right? Because, yeah, I know exactly what I'm parsing. And just when I find something that I can't parse, that's when I have to break. Repeat. Is there something like repeat with something in between? Maybe list? Label, look ahead. Optional. There is not. Okay, bit by bit. White space. This is just going to be repeat of ASCII char space. So here after string I actually have white space. We just use ASCII string. No, this is just string, isn't it? String. Undefined function ws. How do you refer to your own parsers? How do you refer to your own parsers? Okay, so you can ignore stuff. Surely you can refer to your own parsers somehow. Do I need to define it ahead of time? No, undefined function ws1. Def combinator. Oh, defines a combinator with a given name and opts. Okay, so def combinator maybe? Yep. Where am I? Here I am. So def combinator ws defines a combinator given name and opts. This is similar to def-parsec, just a combinator be used with parsec2. What's parsec2? Invokes an already compiled combinator with the name name in the same module. Use case. Parsec2 is useful to implement recursive definitions. Note that while parsec2 can be used to compose smaller combinators, the preferred mechanism for doing composition is via regular functions and not parsec. Via parsec2. Let's see a practical example. Yup. The reason why the above is not recommended is because each parsec combinator ends up adding a stack trace, sure. So what you're instead supposed to do is, oh, just use def. Just use def, apparently. Does this work? Undefined function. Oh no. They say def time. I see they're putting it in a separate module. Maybe that matters. Helpers to import helpers. Okay, undefined function. Import NimbleParsec. Undefined function ws. What? How are they doing this? Date. Yeah, this is just... Oh, here we go. Tag. Tag equals. But I did that and it didn't work. Right? Am I going crazy? Yeah, this clearly doesn't work. Concat tag. Oh, concat tag. Right, because this is a different... Okay. Okay, this works. Fine, good. Right, here, I do not want to actually return this. Ignore. Okay, so now it says game one. Alright. We don't need the helper module. This was not actually very helpful. Okay, I don't actually need the game value either. I do care about that. I do not care about this. I should stop using the debug output because it just moves the real output too far below. Okay, so it parsed correctly 1. Let's tag this with game now. I wonder if this works. Didn't really do anything different. Alright, well, whatever. First, next concat white space. Okay, that deleted the white space. Next up, we have repeat of... Next we have subsets. Yeah, let's just call it subsets and figure this out later. Subsets. Let's just say subset is a subset for now, because that's going to be easier. The subset is a what? It's an integer of -1 character. Then it's some ignored white space. Like this. This needs to be above. Undefined function subsets. Yep, this needs to be concatenated. Okay, so it does game number 3, and the 3 was the thing from here, right? Yeah, 3 blue. Alright, integer 1, and then it's going to be choice of red, green, and blue. Let's just say choice of blue for now, since I don't know the syntax here. This is just string blue. No function clause matching in NimbleParsec choice. What does choice actually look like? 3 arguments. Chooses one of the given combinators. Expects at least 2 choices. Okay. What am I doing here? Oh, I need another concat. Of course I need another concat. The following arguments were given to NimbleParsec choice. Let's just use their example and see what happens. ASCII char. ASCII char A to Z. Oh, this didn't work. No concat maybe? Nope, this also didn't work. How does one use choice? Choice, choice, choice. Empty ASCII. Chooses one of the given combinators. So why does this not work? The following arguments were given. First, an empty list. No. NimbleParsec samples. I wonder if this just has... Does this just have an examples directory? It does. Simple language. Yep. Okay, so here we go. We do ask. They don't have a lot of concats. How is it that they don't have a lot of concats? How are they calling integer? They're calling integer just at the very end. What's interpolation? Here we go. So choice just takes a parser, which is unsurprising. How are they dealing with white space? It just does ignore string. Oh, I have an extra concat, don't I? This is what's going on here. And I don't need to ignore the white space. Do I ignore string? No, I do need to concat this because I have it as a parser. Okay. This is not the nicest language I have ever used. Gonna be honest. Okay. Def combinator P. Recursive definitions require def, right? Okay, they do have a lot of concats as well. So this is not wrong. Question is, how do you do choice here? You do repeat of something and then you just pipe it into choice, which can have just a thing. This should really just work, but it doesn't. Why not? If I... Well, what if I just do this? Choice of blue. Then this is all commented out. Still no. Parsec node, then text. Text is ASCII string. We're just doing something completely wrong, and this choice not actually choice. Parsec. Def parsec. Alright, what's def parsec? Defines a parser. Then this defines a combinator. Def combinator. Def combinator. Name combinator options, which are optional. So why does this not work? Okay, undefined variable blue. Fine. Can I now call you with parsec? No, it has to be like this. No function clause matching in NimbleParsec choice. The following arguments were given. Empty string fine. And it was expecting combinator. Oh, at least two choices. God damn it. God damn it. Right. Parsec. Green. Green, green, green. Green, green. Unexpected comma parentheses are required to resolve ambiguity. Like this? Okay, and now it gave an error, which is fine. Alright, now, do you need to do this, or can we just do it with blue equals string? And now I should be able to just say blue here, right? That should work. Yes. Alright. So the problem was that choice needs at least two arguments. It just errors out, when it just doesn't compile if it's only given one argument. Okay, red, blue, green. Red. Red. Okay, well, this is going to be at the end. These can be uncommented. Okay, so now it parses. Now it doesn't parse anything because I forgot an argument. Okay, so now it parses game num 1, which is the number, right? And then 3 blue, which is what we did here. Okay, but I want blue to actually be something else. What's unwrap and tag? I saw that earlier. That sounded interesting. Unwraps and tags the result of the given combinator in 2 tag. Okay, so unwrap and tag. So if I do it here instead of GameNum, unwrap and tag GameNum1. Okay, yeah, we got rid of that list. Fine, so here. I just want to return a constant value. How do I return a constant value? Can I return wrap? Defines an UTF with the exact location. No. Tag returns a tuple. I don't want a tuple. I want... What do I want? I want generate? Generates a random binary. No. I want ignore, line, look ahead. Where is this? Where is this? A label? Adds a label to the combinator. No. Already saw that. Quoted, reduce, replace. Reduce might be interesting for later. Is there just no way to generate an actual constant? Post traverse, match emitting tag. Nodes. And there has to be a map or something, or a transform. Map, yes. Maps over the combinator results with the remote or local function in call. Call is either in the tuple format or a local or a two tuple format representing a local call or an atom function. Yeah. Okay, because they were expecting you to call integer to string here. So this is I mean, this isn't really what I want, but maybe I can do this. Alright, what happens if I do unwrap and tag? Let's do it the bad way. Unwrap and tag here. Okay, we can see it correctly tags this as red. But if I instead do this here, that would not work. Now this is kind of shit, but what if happens if I do string to atom? String to atom. Unknown call given to map. Got string to atom. Okay, now this is working. You're not normally allowed to do this sort of string to atom thing, but in our case, we know that the input isn't malicious, so should be fine. Probably. All right. So now we have the subset, and I'd like to... Well, okay, so after a subset, we have one of three things. We have either a comma, and then it's going to be more subsets, and then, or we have a semicolon, and then it terminates a subset. So for subset here, we want what? Can I use parentheses? Optional string, comma. Okay, can I just do subset? No. Can do repeat of this. I probably can, can't I? Oh, and then after the optional string, we have, of course, white space. Okay, this is better, looking better. So we have 3 blue, 4 red. We want to ignore the comma. Ignore the comma. Okay, so we have 3 blue, 4 red. Right. And then this parser stops because we end up and then this parser stops because we find a semicolon which isn't parsable by subset. So instead, we're going to do this here. So this is repeat of subset followed by an ignored optional semicolon, and then white space. Protocol enumerable not written for, right, it's not missing a string. Yep. Oh, that didn't work. Why didn't it work? Because it never fails or something of the sort. So what happens if I do this? Does this run? Oh, because... Right, it's a repeat and a repeat, that's probably the problem. I really want something that sounds like repeat 1. Repeat. Allow the combinator to repeat 0 or more times. Beware, since repeat allows 0 entries, it can't be used inside choice because it will always succeed. Yes. For example, because repeat always succeeds, yes, instead of repeat, you want to use times. Allow the combinator given to repeat at least or at most. Okay, so I want repeat 1, basically, or times 1. Times... where is it? Times min 2. Okay, so a subset is going to be times and min 1. A subset has to be at least one thing. Alright, and then of course this didn't work because... Okay, so this parsed something at least. So it goes game 1, then 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green. 2 green, 6 blue, 2 green, right. We don't have... and that's what it left over. Right. The problem here is that this isn't tagged, so we have no idea what each of these things is. So here, after this times, we do unwrap and tag subset. No? I was really hoping that would work. Unwrap and tag expected a single token. Right. It's not unwrap and tag, it's tag. Okay, and then it says subset, subset, subset. Okay. This is kind of alright. But now I just need, now we need to turn this into an actual game state. A game state which I'm now forgetting what actually is supposed to look like. Right, what is this supposed to look like? So we want the output to match this. for example 1. Right, so we somehow need to turn this thing into this. Okay, so this returns a list of some things. Def module, whatever, AoC 3. Def parse line. Now we can match. Now we can match the interface from the other module. Is binary. Do. Then we're going to do. Oh, this is not going to be a single line function. This is definitely not going to be a single line function. It's AoC2.parse of line, and then we do enum.map. We're just going to force the match. We're just going to hardcode the match on OK and result. Let's see if this works, or let's see if this gets us closer to our problem. No. Enumerable not implemented for OK. Oh, so oh, no, this should work. So the result of each AoC, oh, it's a then, not map, right? Okay. Oh, it returns a tuple of a bunch of things. Right. So let's do it like this then. Okay. Then it's the result, and then it's the rest, something, something, something. Okay. Better. So now we have the actual things we parsed. And this is a keyword list. So some of this is going, what do we have to return? We have to return a map. So let's do it like this. Game. Keyword.get res game num. Rest res. Okay, we're getting the game out of it. And now we have to do something with the subsets. Actually, let's write it like this, because this is going to be a mess otherwise. Okay, and then subsets. We're going to take the result, and then we're going to probably filter map through it or something of the sort. This is just going to be subsets. So first off, we want to filter. Filter? No, we want keyword. Not in NimbleParsec, in Elixir. What functions do we have for the keyword module? Drop equal fetch. Fetches the value for a specific key and returns it. Okay. Filter returns a keyword list containing only entries from keywords for which the fun returns a truthy value. Get values. This looks potentially useful. Yeah. So keyword get values is what we want. Keyword get values. Subset. Okay, now we have these things, and they're almost right. We just sort of want to flip them around. Okay, so we're going to do enum chunk by 2. This is going to give us expected a function chunk every. This did not do at all what I thought it would do. Okay, so we have subsets. Oh, and each one of these, of course, each subset is its own thing. So we need to do a new map and subset and subset and then dot chunk every. Okay, this should work now. Yes, this is kind of good. Now we need to flip the entries around. So this is a new map. It takes an x and a y, and it's going to return a y and an x. No function clause matching. Oh, they're lists, not tuples. Easily fixed. Easily fixed. Okay, now we have keyword lists, but what I really want is a num into, let's turn this into a map. Okay, so now we have the same output as below. And holy crap, this was not worth it. Right, I guess let's see that it works. Yeah, we're going to chalk this up to a bad experiment. AoC parse. So here I have to do AoC 3 2105. Oh, that blew up. No, 2105. It's correct. And if I do it here as well, 72422. 72422. Yep, works, but it is ugly. It is way, way uglier than just the manually written thing. Yeah. Pop up. So this is the actual nice solution, and this we're going to refer to as the horrible solution. Ugly NimbleParsec parser. Yeah, that sounds about right. Unused parentheses. And we close this. Yeah. Does this? Yep, this still runs. These are still the right values. Can we move this section below to emphasize that this is not being used? Yes. Okay, and it still runs and it still gives us the right answer. So that's it. This is AoC, this is Advent of Code, day 2. We solved it with a manually written recursive descent parser, which looks a bit ugly, but at least it's not as ugly as the actual NimbleParsec parser. I assume the NimbleParsec one is supposed to be much faster, but haha, this is definitely not worth it for this problem. And I guess the lesson is stay away from NimbleParsec for the following days. I have to say, Advent of Code this year is a lot more difficult than I remembered it being last year. Like, I distinctly remember that last year you could solve basically the first 5 days in a few lines of code each. I don't think any of them actually required a full-blown parser implementation. Or I don't remember any of them having trick questions. Well, I guess it's a year later, so we're all smarter and yeah, we solve harder problems. All right. Well, thanks for listening and see y'all tomorrow.